Hello, my name is Banu Prakash. So my registration number is 19BEC0851. The course name is Microcontroller and its applications. Course code is EC3003, and I am explaining about task 4, lab of microcontroller and its applications. So coming to task 4, our aim is to write an 8051 assembly level program to transfer like my serial number is 32 and registration number is 19BEC0851, and my name is Banu Prakash. We'll draw CWF interface diagrams and calculate delay or count value for timer, serial and interrupt programs in ECE 3003 lab, and theory cat and fat exams as data serially at baud rate 9600 with 8-bit data, 1 stop bit, and to observe the transmitted data in the serial window of the simulator. So tools required are KL software 8051 instruction set and P89C51 article. So our algorithm is coming to the algorithm. Start the program, give the data to the pointer, set timer 1 in mode 2 and baud rate. Start timer 1, declare number of data to be transmitted in R1 register. View the pointer data character by character and move accumulator to SPUF. Monitor the interrupt flag and keep clearing the flag. Repeat the same process till the entire data is transmitted and stop the program. Now, this is the flow chart. First flow chart. Start the program, give the data to the pointer, set timer in 1, and same the follows as the algorithm. It follows the same as in the algorithm. I'm now coming to the table. So here is the table. In the table with the help of memory address, it will label mnemonics, operands, addressing mode is used, and mission cycle required, and mission byte required, type of instruction, flags getting affected by the instruction. So all this will be shown for the memory address of the particular. So this is the program. So here my registration number, my lab slot, and my serial number is there, and this is our program. And this is coming to the results and observation. Before execution of the program, this is the snapshot I have taken, and after the execution, the snapshot is this is the snapshot. Here we can see the output. So coming to the inference, the machine cycle is 1.085 milliseconds, and the amount of memory required to store program in the memory is 25 bytes. Total amount of time required to do an assembly level programming is 20.634 milliseconds. Addressing modes used are immediate, register, relative, and indexed. And immediate is 4, register is 5, relative is 3, and indexed is 2. So type of instruction used is data transfer 6, and arithmetic is 5, and boolean is 2. No flags affected is no flags are affected. Here the data is observed in the serial communication window by transmitting character by character using an appropriate ALB. Now coming to the task 4B, our aim is to write an 8051 assembly language program to get your class serial number data from the PC and display it on P1. So tools required KL software 8051 instruction set and P89C51 arbitrator. So coming to the algorithm, start the program, set timer 1 in mode 2 and baud rate. Start timer 1, move the data from SPUF to accumulator and move accumulator value to P1. Keep clearing the flag and stop the program. Coming to the Now coming to the flowchart, and this is our flowchart as follows as our algorithm, and this is our tabulation, and this is the program code here. So coming to the results and observation before execution, this is our before execution snapshot, and after execution we have taken, so as my registration number is 19BEC0851, so I have taken values for 851. So for 8 we are getting the value here, the ASCII value as 3858, and for 5 we are getting the ASCII value as 35, and for 1 we are getting the ASCII value as 31. So inference, so So inferences for this task is the machine cycle is 1.085 milliseconds, and the amount of memory required to store program in memory is 17 bytes. Total amount of time required to do assembly level programming is 14.118 milliseconds, and addressing modes used as immediate 3, register 4, and relative 1. Type of instruction used as data transfer 7, logical 1, boolean 2, and arithmetic 1. Flags affected is no flags are affected. Result here: a few digits ASCII values are taken from the PC and then displayed on output by writing an ALP. Now coming to 4C, to write 8051 ALP and to get data from the PC and display it on LEDs in ASCII values on port 1 and port 2. So tools required here are SQL software, 8051 instruction set, and P89C51RT2 microcontroller. So coming to the algorithm, we will start the program and set timer in mode 2 and mode start timer 1, move the data from SVB to accumulator, and move the accumulator value to port 1, and here move the accumulator to port 2 also. Keep clearing the flag and stop the program. So the flowchart follows as algorithm which is stated above, and here is the program for task 4C, and this is the tabulation, and this is the tabulation task 4C follows, and the results and observation for before execution is for before execution. Here this is the code, and after execution, as my name is Banu, first letter of B ASCII value will be 42. Okay, for B the ASCII value is 42, and for the H the ASCII value is 48, and for A the ASCII value is 41, and for N the ASCII value is 0x4e, and for the U the ASCII value is 0x5. So here are my ASCII values of my name Banu, BHANU. So coming to the inferences, the machine cycle is 1.085 milliseconds, and the amount of memory required to store program in memory is 13 bytes. The total amount of time required to do assembly level programming is 11.946 milliseconds. Addressing modes used is immediate 2, direct 2, register 2, and relative 1. So type of instruction used as data transfer 4, branching 1, logical 1, arithmetic 1, and boolean 1. So flags affected are carry flag affected. Here the ASCII values of the letters in the name are obtained with the port 1 and 2 by serial transmission by writing 8051 ALP in KL software. So coming to the task 4D, aim to write an 8051 assembly level program to send to the PC the message my name is MICROTASK4 and my registration number is 19BEC0851. I will upload all the tasks in meetup on time. So tools required are basically again and KL software, 051 instruction set, and P89C51RT. So coming to the algorithm, start the program and make P2 and input, set the timer 1 in mode 2 and baud rate and start timer 1, load pointer for message, get the character, if last character get out, otherwise call transfer, read data on P2, transfer it serially and get serial data to display it on release, and now stop the program. So coming to the flow chart, and this is our flow chart as follows as the algorithm. So this is our program. This is our program code, and here the database is typically represent my name, Banu Prakash, and my registration number. Here you can see, and I will upload all the tasks. So this message should be displayed on our PC. So this is the tabulation of our project, of our task, and this is the snapshot before execution of our code, and this is the snapshot after execution of code in hexacode. So this is the hexacode values we will see as output. For ASCII code, we will see the output as Banu Prakash 19BEC0. We'll upload, and this is the output. So our output is verified. So coming to the inferences, the machine cycle is 1.085 milliseconds. Amount of memory required to store program is 24 bytes. The total amount of time required to do assembly level programming is 17.376 milliseconds. And addressing modes used as immediate 1, register 3, absolute 1, and direct 5. So types of instruction is data transfer 7 and branching 1 and logical 2. Flags affected or no flags are affected. So result the message icon 19BEC0851 will upload all the tasks in delay to bit of on time is being observed on the serial message window by writing 8051 ALP in KL software. So coming to the task for our aim is to write a program to send a message. So theory slot is 66, my theory slot is 66, so theory slot is E2 and my theory serial number is 66. My name is Prakash. Assure you that I will answer all my ALP in a tabular column with algorithm, manual calculation and flowchart in CAD2 and term and exam to the serial code. Assume SW is connected to the pin P1.2. So tools required are SQL software 8051 instruction set and P89651 RD2. So algorithm is start the program set timer 1 in mode 2 and power and start timer 1, make SW and input, check the SW status with beacon, set SMOD high for 9600, write beacon and send message read beacon and set SMOD low for 4800, write PC on and load address to the message, read value using pointer, check for end of the line, set value to the serial code, move to the next value and repeat the process and end the program. So flowchart follows as the algorithm. So this is our tabulation follows. And coming to the results and observation, before the execution, this is the before execution snapshot, and after the execution, this is our snapshot. So here the machine cycle is 1.085 milliseconds and the amount of memory required to store program in memory is 45 bytes and total amount of time required to do assembly level programming is 36.924 milliseconds and addressing modes use this immediate 4, direct 5 and index 1. So type of instructions are used as data transfer 10, branching 6 and boolean 7 and arithmetic 1. Flags affected is carry flag is affected and in one case a accumulator flag also is affected and overflow also, like 3 flags are affected. So result comes to this. Here comes to the result. Hence to write an 8051 ALP to get the data I want to fetch from MICROTASK4 serial number 30 to assure you that I will answer all my ALP from memory location and send that through to the serial port by assuming SW is connected to the pin P1.2 and results are verified manually. Thank you.